Welcome back. In this video, we are going to talk about risk aversion and insurance. But before we do that, let us revise what we have learned about risk. Risk is related to uncertain outcome. There is some probability distribution that different things can happen with different probability. When we are able to enumerate them and we are able to associate a probability with each of the possible outcome, we say the situation is risky. As opposed to this is uncertainty, when either we are not able to list all the outcomes or we are not able to associate a probability distribution with all the outcomes. So that's a difference between risk and uncertainty. So let us just to understand, let us take a person, let us say Sohan, and Sohan is facing good as well as bad weather. Let us say that good weather can happen with probability 2 by 3 p, and bad weather can happen with probability 1 by 3, that is 1 minus p. Let us say in good weather Sohan gets 600 kg of output, and in bad weather Sohan gets 300 kgs of output. So we can say that this is P, or P is a bad word, let us say C, G, and this is C and B. Why didn't I put P? Because P will be reserved for probability here, I have already used it. So we can calculate the expected value. Expected value is going to be P multiplied by C of G plus 1 minus P multiplied by C of B. And so we can say if we have CB here and CG here, we can say CB is basically E expected value divided by 1 minus P divided by 1 minus P CG. And this is equation of a line. So this is what we are going to get. There will be a line, and how much is the slope of that line? Slope of that line is minus of P divided by 1 minus P, which is in this case is 2 by 3 minus 1 by 3. So minus 2 is the slope. And so what would be the intercept here on the vertical axis? If we calculate the expected value would come out to be 500. And so this is a line where expected value is same everywhere. So this is going to be 500, and 1 by P is 1 by 3. So the vertical intercept is going to be 1500, and similarly if you calculate, we can say vertical intercept, and horizontal intercept similarly you will calculate, it's going to be 750. And so we can draw the line, it's going to be something like this. This is 1500 and this is 750 vertical intercept. And where is this point? This point is somewhere here. We can say this is 600 and this is 300. And we can also draw guaranteed consumption line, and we have learned about it earlier. The guaranteed consumption line is going to be a 45-degree line, and this will be at 500 because that corresponds to EV, that is the fixed. So that's what we get here. I just wanted to revise and understand that what are the things involved. Now we have also learned about risk aversion, risk loving, risk neutral. We say that for risk aversion preference is convex, and so it's going to be something like this or this. So if we move in this direction, utility is increasing. So if we can move in this direction somehow, then of course, till this point utility would be increasing. So any person would be interested, any person who is risk averse would be interested in making, let us say this point is A and this point is B. So any person would be interested in moving from A to B because it increases the utility of this particular person. So that we should understand. Now let us understand little bit about insurance, and then we can get back to this graph once again. So first of all, what do we mean by insurance policy? So we can say that insurance policy is basically a contract between two parties such that this contract reduces the financial loss of policy holder in case of a bad outcome, in case of a risky event. So that's what insurance policy is. So basically a contract to reduce financial loss in case of a bad outcome. Now what is premium? Premium is the amount that, let us say we are talking about Sohan, that premium is the amount that Sohan pays to insurer to get, to get compensated for that financial loss. So amount paid by policy holder okay, to the company providing the insurance. And benefit, we can say this benefit, we can say premium is M, benefit we can say is B. Benefit is the amount that insurance company pays to the policy holder in case of the financial loss. And what is actually fair insurance? This is simply that, think about the situation that benefit gets paid in case of bad outcome, and bad outcome is happening with probability 1 minus p. So this is getting paid in only case of the bad outcome. And nevertheless, that premium has to be paid before the event, before the state of nature is realized. So the premium is paid irrespective of the outcome. So we can say the payment is basically M by the insurance holder, and if this is equal to 0, then we can say it is actually fair insurance. So in that case, M has to be equal to B multiplied by 1 minus P. If we take this example, the earlier example, we can say the probability that good weather happens with probability 2 by 3, bad weather happens with probability 1 by 3. What would be the actually fair insurance? That if Sohan gets compensated in case of bad weather, then for 1 rupee he should be paying 1 by 3 rupee as premium. Then only it's actually fair. Or if he gets compensated in the good weather, because just good and bad are named here, then for getting compensation of 1 rupee in case of good weather, he should be paying 2 by 3 rupee as insurance premium in ex ante manner before the state of nature, good or bad, have been realized. And that's what would be the actually fair insurance. So very clear that if we mark it here, in blue color, then this is the zone in which the Sohan would like to move to improve his utility, and everything on this line, this red line, that red line is about it's giving you the constant expected value of the outcome. Everywhere it's giving you the same outcome. So all the points here represent actually fair insurance. Now we should understand fair, or fair we have already figured out, the full insurance versus partial insurance. In full insurance, the payment is about equal to the loss. Of course, premium has to be deducted, but here payment from insurance company is equal to loss. And in partial insurance, the payment from insurance company is less than the loss. So that's what we have to understand. So, let me draw it once again. This is the same line that we are using as an example. 750, sorry, this is 1500, this is 750, this is good, this is bad outcome, this is 500 guaranteed that you are getting, and here is, this is 600, this is 300. So, how much is the loss from the so from expected value, you can move, this Sohan can move in this direction. So, we can say the full premium in this case is this amount, that how much is the payment, 300 is the payment because that is the loss, minus 100 because that is the, for 300 the payment has to be 100 because for 1 rupee the payment insurance premium is 1/3 rupees in case of bad outcome. So, this is 200, and in this case this is just the premium, which is basically 100. There is no payment from insurance company, and both will bring this Sohan to at 500, that is guaranteed consumption for Sohan no matter what is the state. So, that is the full insurance. Mind you, we are talking about fair insurance. Why? How it is fair? That for 1 rupee the payment has to be 1/3 rupee, or for M is the premium, it is equal to benefit multiplied by the probability of happening the bad outcome, and in that sense it is fair. Now, the idea is that how much of insurance Sohan should buy if it is a fair insurance. So, of course, we have already figured out, and that is where the expected utility formulation would be very, very helpful. How much is the utility, the expected utility of this person with probability P. Let us check once again. This is the probability P, good weather happens. With probability P, consumption is W naught, and W naught is the initial wealth, and we can say that of course he is paying a premium. How much is the premium? The premium is benefit multiplied by the probability of happening the bad weather. So, we can say it is B multiplied by 1 minus P. So, this is B multiplied by 1 minus P. This is the consumption that Sohan has in good weather. W0 is the initial wealth, and in good weather there is no loss, but he has paid this much of a premium because he wants B amount of benefit in case of bad weather. And with probability 1 minus P, what happens? In the bad weather there is a loss, that is L, that he incurs, and then he also gets benefit, that is B, and how much he has to pay? No matter whether it is good weather or bad weather, he has paid right at the beginning. So, this is B 1 minus P, and so his consumption is basically W0 minus L, and this is B and B will get cancelled, and so it is basically beta BBP, that is what he has. And so, his total utility, expected utility, let us write here, expected utility is basically P multiplied by U W0 minus B 1 minus P plus 1 minus P, because expected utility, this is the consumption with probability P. So, this is the utility coming from that much of consumption, and P is multiplied, as this is the probability, 1 minus P multiplied by U W0 minus L plus B plus P. He has to decide how much of benefit to buy. Should he go for full insurance? Should he go for partial insurance? So, he should be maximizing his expected utility with respect to P. So, what would be the first order condition? If he does this maximization, P U dash W0 minus B multiplied by 1 minus P, and he is differentiating with respect to B. So, this is what you are going to get here, minus 1 minus P. And then in the next 1 minus P U dash W0 minus L plus BP, you are differentiating this respect with B, you are left with P, and this has to be equal to 0. So, because you have a P and 1 minus P term on both sides and the right hand side is equal to 0, so you can very well cancel P, 1 minus P, 1 minus P, P, this you can cancel. And so, this can further be written as U dash W0 minus B1 minus P, and if you, because this is a minus sign, you are taking it to the other side, and the left side hand side you are left with U dash W0 minus L plus BP. So, on both sides the utility should be the same, and when utility is the same, when you are on this particular line. So, what does this give you? That W0 minus B1 minus P has to be equal to W0 minus L plus BP. W0 will get cancelled. If you take L, what you are going to get is bring L on the other side. You bring this L on the other side, this L, and take this B 1 minus P and BP on one side. You will get this 1 minus P plus BP. You are going to get L is equal to B. So, you should buy benefit for the whole loss amount. It means a risk averse person in case of full insurance, in case of fair insurance should always go for full insurance and not partial insurance. There is another way to look at it. If you have the same line, okay, and that we have figured out, this is the where the point of tangency is. This is consumption in good weather, consumption is bad weather, this is guaranteed consumption line, this is fixed expected value line. So, this is where your optimization is happening. So, how much is the slope of this line? The slope of this line, if you go back to our derivation earlier, the slope of this line is minus P multiplied by minus P. The slope here is minus P divided by 1 minus P, and this is coming from expected utility. So, how much is the marginal rate of substitution? The marginal rate of substitution is P, whatever is the consumption, let us say P U dash CG dash, because it is not going to be depending on that how much is the premium and all, and this is going to be 1 minus P U dash CB dash. And so, this has to be, the slope has to be equal to MRS. So, minus P divided by 1 minus P, P divided by 1 minus P, this will get cancelled, and this you are left with U C dash G U dash C dash B. What it means? That marginal utility on the good side should be equal to the marginal utility on the bad side. As we know, the marginal utility is diminishing in case of convex utility function. It means that C dash G has to be equal to C dash B. So, it has to be on this line, and this is the fair insurance is keeping you on this particular line. Therefore, this is where you will end up. Let us talk about the case in which we have less than fair insurance. We are going to start with the same example, the example of Sohan, and he can have, let us say, a consumption of 600 if weather is good and consumption of 300 if weather is bad. good happens with probability 2 by 3, and bad happens with probability 1 by 3. So P is equal to 2 by 3. Expected value comes out to be 600 multiplied by 2 by 3 and 300 multiplied by 1 by 3. This we have already done, and this is equal to 500. So we can have a scale on which on x axis when things are good and on y axis when things are bad. That's what we have done. No, we have done opposite. So let us put here bad and let us put here good, and then we can draw the line. Equation is given here. This is the equation we have. We can write it. CB is equal to EV divided by 1 minus P divided by 1 minus P, and that is CG. That's what we had. We can check once again. Exactly, this is what we had. And so we can draw the line which gives us the same expected value, and this line comes out to be something like this, and here is 1500 and here is 750, because then only the expected value is going to be equal to 2 by 3 and guaranteed consumption of 500. This is the 45-degree line that we have. And the fair insurance means that if Sohan is getting compensated in case of bad weather, then 1 rupee of benefit will cost ex ante 1 by 3 rupees. And therefore, you know what's happening. So here if we see, let us say it is 600 and it is 300 and this is 500 and this is 500. So this we have already seen. This is 300 plus 300 rupees of benefit minus premium, and that is equal to 500, and this is 600 minus 100 rupees of premium, that is 500. What it means that 100 rupees of premium that is paid ex ante is giving 200 rupees of compensation in case of bad weather and 0 rupees of compensation in case of good weather. So the ratio is 2. Okay, 1 rupee of premium is giving 2 rupees. So, and that is the fair insurance. That's what we had figured out, and we described so that we understand what is unfair in insurance. It means the 100 rupees of premium will give something less than 200 rupees. That's what would be the unfair. Let us say 100 rupees of premium is giving only 100 rupees, for example, only 100 rupees of compensation in case of bad weather. Okay, or in other word, we can say 50 rupees will give only 50 rupees. So what is going to happen? Earlier in case of fair insurance, the movement was along this line, because the slope of this line is, if you remember, the slope is P divided by 1 minus P, which is exactly 2. So P is 2 by 3 and 1 minus P is 1 by 3. So the ratio is true. So movement is along this line. So if ratio is going to be less than 2, then movement cannot be on this line. Movement is going to be somewhat like this. This is the way it would move. This is the way it's going to happen. The movement is going to be, that's the blue line here, will represent less than fair insurance. And so I would not get into the details. What we had figured out that for risk aversion, this is the way indifference curve look like. And so here, of course, Sohan cannot achieve this particular indifference curve. He is going to get to a lower indifference curve, which will be perhaps something like this, and this is where the tangency is happening. And so clearly a risk averse person should go for partial insurance in case of a less than fair insurance. And how much insurance he should get, it will depend that how convex this indifference curve is. What does it mean? That the amount of insurance would depend on the risk aversion. What we had figured out in case of fair insurance, that no matter how risk averse that person is, he will always go for full insurance as long as that person is risk averse. So there it didn't matter, the degree didn't matter, but here in this case degree is quite important, and that's what we understand. This person should not be reaching here, because he can always do better by having the partial insurance, and that's what we are getting in this particular case. Please remember that the argument I have given you is geometric in nature. I didn't give you mathematical earlier. We had mathematical as well as geometric argument, but here I am giving you only geometric argument, and the argument is predicated on the way the indifference curves are shaped. What we have is diminishing marginal utility. So that should be clear to you. So that's enough on fair and less than fair insurance. We can also try to understand the value of insurance, how to figure out how much is the value of insurance. So let us do in case of fair insurance. We can understand here that this is 1500, this is 750, this is the guaranteed fixed expected value, and then we have here, let us say earlier this person was here, and that is 600, and here is 300, and after getting insurance, his indifference curve that he is able to achieve is this one, and before getting the insurance he was at this point. Let us say perhaps again this is the way things are. So in equivalent term, let us say earlier he was at B, finally he reaches at A, and this we can say H. So he is indifferent between B and H. So we can say the value of insurance is equivalent to the certainty equivalent that's coming from moving from H to A, and because this is, one can say this is what the certainty equivalent is, and that's what is the value of insurance for this particular person. So we have to look at the difference, how much of the increase in utility is coming from after getting the insurance. So one has to compare A and H, and A and H are easier to compare than A and B. A and H are easier to compare because A and H are both on guaranteed consumption line. So one can also describe it in terms of the consumption. Okay, and similarly I request you to figure out what is going to be the value of insurance in case of less than full insurance.